adjoint of any matrix? First theorem, which says that if A multiply with its adjoint or adjoint of any matrix is multiplied to itself, the product is always
Det of A into identity matrix.
very good. Det of A into an identity matrix. Super good. Second one is if A and B are non-singular, A and B are non-singular matrix of same order, then A into B and B into A also non-singular. I'm saying you're not saying anything. And third one is determinant of A into B, determinant of product of two matrices is equal to determinant of product of individual, right? So product of the individual determinant. So det of A into det of B. Any question? And fourth result we have seen, what is the determinant of adjoint of any matrix? If I say that if A is the square matrix of order 3, then what is the determinant of adjoint of A?
Det of A to the whole square.
So det of A to the power 3 minus 1. Understand the order minus 1. Any doubts, students? Shall we proceed with next one? The next is very important formula, inverse of the matrix. No, before inverse of the matrix, if A is singular, if A is a square matrix, a singular matrix, then det of A will be equal to girls side. If A is singular, determinant of A is equal to what?
0.
Sixth one, if B is a non-singular matrix, B is a non-singular matrix, then determinant of B, which is not equal to
0.
0. So determinant of any matrix 0. So those matrices are singular matrix. Determinant of any matrix are not equal to 0. Such a matrix are called as non-singular matrix. And the very important theorem is, when will be A inverses A is an invertible matrix. If A is invertible, hope you remember what is invertible means, whose inverses exist. A is invertible if and only if, come on.
Det of A is not equal to 0.
A is not 0.
That is correct. So A is invertible if and only if determinant is not equal to 0, what do you call as?
Non-singular.
Singular matrix.
Non-singular matrix. If and only if A is a non-singular matrix. What is the meaning of this one? Whenever you are finding A inverse, it is your duty whether its inverse is existing or not, by showing determinant of the particular matrix not equal to 0. Understand? So if A inverse is existing, then what is the formula we have to use to find out inverse using adjoint of the matrix? Then A inverse is equal to 1 by determinant of A into adjoint of A. This is the formula. You can use it whenever, if determinant of A not equal to 0, then inverse is exist. How to find out inverse of the matrix? A inverse is equal to 1 by determinant of the matrix into adjoint of the matrix. Is that clear? And one remark is, if determinant of A, which is equal to 1, determinant of any particular matrix is equal to 1, then what are the changes will happen into inverse formula? Then A inverse will be equal to what? A inverse will be equal to,
Adjoint.
very good. A inverse is nothing but the adjoint of the particular matrix, adjoint of A. Clear? So these two formula we are going to use it in upcoming exercise. So if determinant of A is not equal to 0, you can use this one. If determinant of A is equal to 1, A inverse is equal to adjoint of the matrix. Understand? Understand or not?
Yes.
So you know that how to find out adjoint of the matrix, adjoint of 2 by 2 matrix. What is the shortcut? Finding adjoint of 2 by 2 matrix.
Change the primary diagonal elements and change the sign
Very
of
good.
the other diagonal.
Exchange the leading diagonal element and change the sign of the non-leading diagonal element. That's it. Okay, come on. We are in exercise number 4.5. We are exercise number 4.5 and we have to proceed from fifth question. What is the fifth question onwards? Fifth question says that find the inverse of the each of the matrices if it is exist. You have to ensure whether inverse is existing or not for each of the matrices given by checking determinant value is what. Understand? So from problem number 5 to 11. Shall we start? One of me, please help me out to write the matrix A. Oh, sorry. So we are going to start with the fifth problem. Let us take the given matrix as A. Tell me what is the given matrix?
2
2
2
minus
minus
4
yes.
3.
Thank you. So they're asking whether its inverse is existing or not. How we can ensure whether its inverse is existing? We have to find out determinant value. Come on, tell me what is the determinant value? 6 minus of minus, it's plus 8. What is the answer? 14. So 14 which is not equal to 0, therefore A inverse is exist. Writing this is very important step. Ensuring. Understand? So A inverse is exist. Then Yash is there? Yash? Yash? Come in mic, Yash. Oh, it's not there. Okay. Okay, it's fine. Shreya, tell me what is A inverse formula? A inverse is equal to
Adjoint of A by mod determinant of A.
into adjoint of A. Understood? Now you know the value of determinant of the matrix. Now it's your duty to find out adjoint of the matrix. Shall we find out adjoint of the matrix? This is A matrix. Then what is the adjoint of A? Use the shortcut and say the answer. Kritika, adjoint of A is 3, 2, plus 2 and minus 4. Am I right?
Yes.
Yes, sir.
So then A inverse is equal to what? A inverse is equal to, we know determinant is 14. So 1 by 14 into adjoint of the matrix. That is 3, 2, minus 4 and 2. This is the required adjoint of the matrix. Sorry, this is the required inverse. This can be, you can take the 14 inside and do it. Nothing wrong. Further, if you want to simplify, you can do like this. A inverse, the exact A inverse is equal to 3 by 14, 1 by 7, minus 2 by 7, and 1 by 7. So this is the exact inverse of the matrix. Okay, I just want to tell you that here to find out inverse of any particular matrix, what are the first step that you're doing? Step 1 is what? Step 1, you are finding out the determinant of the matrix and showing that which is not equal to 0, therefore A inverse is existing. That's the first step. And second step, you need to write the inverse formula. Inverse of any matrix using adjoint of the matrix. A inverse is equal to 1 by det of A into adjoint of A. The second step. Third step, you need to find out adjoint of the matrix. Third step is what? Finding adjoint of the matrix. It's 2 by 2, you know the shortcut. After finding adjoint, the fourth step, you need to substitute the adjoint and determinant value, simplify. That is the required inverse of the matrix. The steps are clear, my dear students. Is the steps are clear?
Yes, sir.
Okay, I have done this fifth one. Sixth one is homework. Sixth one is homework. Please make a note of it. Now, the challenges begins when we are finding the inverse of 3 by 3 matrix. The challenge begins only when finding the inverse of 3 by 3, because finding the adjoint of 3 by 3, you all know that we need to go for cofactor of each element. So adjoint of 3 by 3 is what? Adjoint of any matrix is transpose of the cofactor matrix. Okay. So what am I going to do is, instead of finding the cofactors, I have a shortcut method to find out the adjoint of 3 by 3. Shall we learn that?
Yes, sir.
So going like a general way, like finding cofactor of every element, forming a cofactor matrix and taking a transpose of it, that is the required adjoint of A. You all know that. Okay. How to verify that? I'll tell you the shortcut method how to get exactly the adjoint of the matrix. Okay. Now we are going to find the inverse of 3 by 3 matrix. I think question number 7. I have a problem to teach you the shortcut. Let it be the NCERT problem. Let us concentrate on this. The problem goes like this: finding inverse of a matrix using shortcut. Shortcut method. The given matrix A is 1, 2, minus 2, minus 1, 3, 0, 0, 2, 0, minus 2, and 1. So this is the A matrix. What are the first step? First and foremost step, what is that? We need to find out whether inverse is existing or not. For that, we need to know the determinant of A. Find out determinant of A by expanding C1 wise. Tell me what is the determinant value by expanding C1. If you start finding it, it's 1 time of 3, yes, and plus 1 time of what is the plus 1 time of it? What? So 2 minus 4. Am I right? So what is the answer? You're getting 3 minus 2. So what is the determinant of A? Determinant of A is 1, which is not equal to 0. Therefore, you can conclude A inverse is exist. Then A inverse is exist. What is the A inverse formula? A inverse, and importantly, you can make a note of it. Determinant of A is 1. Then A inverse is equal to
Adjoint of A.
very good. So A inverse is equal to 1 by 1. Actually, 1 by det of A into adjoint of A. Since the determinant of A is 1, so that 1 by 1 is 1. So you need to directly go for adjoint of A. So A inverse is equal to the required adjoint of A. Okay. How to find out adjoint of 3 by 3 matrix in a shortcut way, in a shortcut manner? So I'm going to teach the shortcut here. Students, write the given matrix as it is. Write the given matrix 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, and 1. Is that correct? Next, what you have to do is repeat C1 and C2. After this, what is C1 here? This is your C1 and this is your C2. Repeat them. So write C1 here, that is 1, minus 1, 0. And write C2, that is 2, 3, and minus 2. Now, after this, after writing this is your R1, this is your R2. Repeat R1 and R2. R1 is what? 1, 2, minus 2, 1, and 2. R2 is minus 1, 3, 0, minus 1, and 3. So writing like this, so this this will help you to write the adjoint of the matrix in a shortcut way. After writing this, students, I'll repeat how to write this one. First, to write the given matrix. After that, right hand side, you have to repeat C1 and C2. After that, repeat R1 and R2. You'll be getting a 5 by 5. In that 5 by 5, delete the first row and first column. You'll be having 4 by 4. In that 4 by 4, take this 2 by 2 determinant. Take this 2 by 2 determinant. I'll use some other color. Yes. Now get ready with your adjoint of A. The required adjoint of A is going to be a 3 by 3. Now you have to take a 2 by 2 determinant. What is the determinant of this? 2 by 2 determinant. What is the answer?
3.
3.
Yes. So I'll write here 3. I'll use a different color. I take the determinant of this minus this one. So 3 minus 2 times of 0, it will give you, this is 3. And then the next element is going to come here is, you have to take the determinant of these two. Take the determinant of these two. Taking a determinant of column wise, I'm writing the adjoint in a row wise. I repeat, taking a determinant column wise, taking a 2 by 2 determinant column wise, and writing the adjoint of the required matrix by row wise. So now you take the determinant of these two, this minus this. So minus 2 into minus 2 plus 4. Plus 4 minus 2 is what?
2.
Plus 4 minus 2. Plus 4 minus 2. It is 2, correct? It is 2. And the element is going to come in the first row. Last element would be taking a determinant of this. Take a determinant of these two matrix. Take a determinant of this 2 by 2. So what is the determinant of this 2 by 2?
6.
Yeah, it is going to be 0. Minus of minus 2 into 3, that will be 6. Done. So I repeat, we are taking the 2 by 2 determinant column wise in the diagram, but we are writing in a row wise. Don't forget, don't change this order. Taking a determinant of column wise and writing in a row wise. Clear, students? My dear students, is that you're able to follow this?
Yes, sir.
Next, we have to go to this. Yeah. Next, we are going to write the second row of our adjoint of the required matrix. Now you have to take the determinant of these two. And next is, yeah, take a determinant of these two. 0 minus of minus
1.
plus 1 plus 1. And then next you have to take a 2 by 2 determinant, this 2 by 2 determinant. Okay, tell me what is that? Here we have 1. Here we have 1. Okay. This 2 by 2 determinant is also 1. 1 into 1 is 1. Minus 2 times of 0 is 0. Next, this element is going to be determinant of what? Determinant of these 2 by 2. Quick.
2.
2.
Understand now? So minus 2 into minus 1 is plus 2. Plus 2 minus 1 time, 1 time of 0. This is 1 time of. This is 1 here. So this will give you 2. This is 2. Understand? And next is taking a determinant of this, and this, and write the row. Okay, take the determinant of these 2 by 2. Minus 2 into minus 1 is what? Plus 2. Understand? And now to write this element here, take the determinant of these 2. What is the determinant? Come on. Also plus 2. And the last element that you need to take a determinant of these 2 by 2.
5.
Quick enough is, what is the answer? It is 5.
5.
Understand, students? So you feel this is easy or difficult, the shortcut? Or you're comfortable with the finding cofactor matrix?
So cofactor matrix is better for me.
Okay, then that's fine. That's fine. Use it. Use it. Preferably, I would prefer you to go with the cofactor and do it. But if not, see why this changes now. Why we are taking determinant column wise and writing row, because we are taking the transpose of the comatrix. Yes, transpose of a cofactor. That's why we are writing like that way. So those who are feeling comfortable in that, you do that way. No problem. Okay.
So can we use this method in examination?
Not advisable, because by verification you can do it. But when you do in the examination, you should go in the cofactor wise, cofactor element. So next problem that I'm going to teach you through cofactor wise. So this is, I just want to share with you. That's why I gave you. So here you can conclude. So A inverse is equal to what? A inverse is equal to this 3, 2, 6, 1, 1, 2, and 2, 2, 5. This is the required A inverse. So okay, let's continue from the NCERT problem. Yeah, I'll do the 7th one. I'll do the 7th one here. So 8, 9, 10 that you're going to do as a homework. Okay, come on, tell me. What is 7th problem? What is 7th problem says? Let us take the given matrix as A. Tell me the 3 by 3 given matrix.
1, 2, 3.
1. Thank you. Then
0, 2, 4.
very good.
0, 0, 5.
Okay, that's it. Understood. This is it. So first step is what? What are the first step you need to do? We have to ensure whether its inverse is existing or not by checking determinant value. Okay, so what is the determinant of this matrix? By expanding C1 wise. Expanding C1, what is the answer? I'm sure determinant of A would be
10.
very good. Determinant of A is 10. You can say that this is not equal to 0. Therefore, A inverse is exist. Many of you ignoring this step. Don't ignore, this carries a mark. By verifying whether its inverse is existing or not, this carries 1 mark. Don't forget. Okay, what is the next step? If A inverse exists, what is the formula of A inverse? A inverse is equal to
Determinant of A multiplied by adjoint of A.
1 by det of A into adjoint of A. Okay, to find out adjoint of A, what is adjoint of A? Adjoint of A is what? Transpose of the cofactor matrix. What is that? A11, A12, A13, A21, A22, A23, A31, A32, and A33. It's your duty. You need to find out the cofactors of every element. So that's a transpose. Okay, guys, please tell me the cofactors. You know the cofactor formula? Cofactor of any element which lies in the ith row and jth column. What is the formula? Aij is equal to minus 1 whole power I plus j into minor of the element. Clear? Use this formula. Quickly tell me what is the cofactor of first row, first column. First row, first column would be determinant, na?
10.
First row, first column, 10. Very good. Then cofactor of first row, second column, it should be minus something, okay? Minus of,
0.
minus again, come again.
0.
0.
Very good, very good. Excellent. Then what is the cofactor of A13? Quickly tell me, what is that?
0.
Very good.
0.
What is the cofactor of 21?
Minus 10.
Minus 10.
Very good. What is the cofactor of second row, second column?
5.
Super enough. Then second row, third column.
0.
0.
Good. Then third row, first column.
2.
Good enough. Then third row, second column.
Minus 4.
Good. Third row, third column.
2.
That's it. It's you have done. You're able to find the cofactor in a short manner. Then that's okay. You can directly go to it. So therefore, with the help of cofactor elements, you can form a cofactor matrix. Therefore, the required adjoint of A is the transpose of it. What did it? Okay, you are substitute and take a transpose. That's not nothing wrong in it. So 10, 0, 0, minus 10, 5, 0, 2, minus 4, and 2. Take a transpose of it. Take a transpose of it. Therefore, the adjoint of A is 10 minus 10 2 0 5 minus 4 0 0 2. Am I right or wrong?
Yes, sir.
Then you can
Right.
conclude. Then you can conclude that A inverse is equal to 1 by det of A, that is 10. Determinant of A is 10, na? 10 into adjoint of the matrix. You know what is adjoint of the matrix is? So 10 minus 10 2 0 5 4 0 0 2. Take the 10 inside. So that is the
Sir,
required
minus
A.
4.
Yeah, you're right. Minus 4. Thank you. It's minus 4. Just take 10 inside. You'll get the required A inverse is 1 minus 1, 1 by 5, 0, 1 by 2, minus 2 by 5, 0, 0, 1 by 5. Am I right?
Yes,
This
sir.
itself,
Yes, sir.
it's correct, but going forward, simplification, this is the perfect answer. This also I'll give a mark. Nothing wrong. So, are you all clear with the steps which are involved to find out inverse of 3 by 3 matrix? All of you?
Sir,
Yes.
sir, while writing the adjoint of A, can we just directly write the transpose of it?
Of course,
Instead of
you can
writing
write.
this
Yeah. You can directly write. Take the transpose of it. Writing this element as row, writing this element of second row, writing this element of third row. That's good. Nothing wrong.
Okay, sir.
You definitely will be writing like this way. Understand? So you
Yes.
keep this in your mind and express this as R1, express this as R2, this is R3. That will give you agenda.
Okay, sir.
So you can avoid this step. For this whole question, you'll be getting 5 mark. This is very, very important 5 mark. Please make a note of it. 5 mark. Very important 5 mark. So if you're thorough with this, you can believe that you have a 5 marks in your hand. Okay, so understand the understand the importance of learning inverse using determinants. Guys, I'm going to give you question number 8, 9, 10 as a homework problem. Please make a note of it. Homework. Same thing, na? I have done 7, same manner you can do the 8, 9, 10. Homework 1, this is homework 1, this is 2, this is 3, this is 4, and additionally that I'm going to add with homework 5, this asked in 2019. Okay, this question. What is that question is, yeah, I think it's here. Find the inverse of this matrix. This is also 3 by 3. 0, 1, 2, 1, 2, 3, 3, 1, 1. This is homework 5. Quickly copied. Those who are finished, have a look on question number 11. Let's start. Make it fast. Question number 11. Problem number 11. So tell me the given matrix. Let us take the matrix is A. Konami, please help me out.
1,
One.
Okay.
0,
Okay. Then
0,
mm,
cos alpha, sin alpha,
okay.
0,
Okay.
sin alpha,
Okay.
minus cos alpha.
Thank you. This is the required A matrix. For this, we need to find out the inverse. So first step. What are the first step? Yash, where is Yash? What are the first step involved in this? Sudarshan,
Yes, sir.
what are the first step involved to find out inverse of the matrix? First step. We have to ensure whether its inverse is existing or not. How we can ensure? By checking the determinant of the value, determinant of the given matrix. Tell me what the determinant of the given matrix. Sudarshan, are you following or not?
Yes,
That's
sir.
simple
Ma'am.
thing. Expanding by C1 wise, you'll be getting minus cos alpha square minus sin alpha square. So that it is, you take minus outside, cos alpha square plus sin alpha square, you'll be getting determinant of A would be is equal to minus 1. How many of you got it? Which is not equal to 0. Therefore, A inverse is exist. Then A inverse is exist. Then what is the formula? Then A inverse is equal to 1 by det of A into adjoint of. So we can directly write minus time of adjoint of A. Why it's minus time? Anybody knows why it's minus 1? Minus time of it?
Because 1 by minus 1 is minus 1.
Very good. You know the logic. Okay, that's why we are putting, since determinant of A is minus 1, 1 by determinant of A will be minus 1. Okay, quickly tell me adjoint of A. What is the adjoint of A? If you know the adjoint of A, negative of adjoint is the required inverse. That's it. Okay, one by one, tell me what is cofactor of A11. Make sure the cofactor of A11 is +1. +1 or -1? It should be -1, no?
-1, sir, -1.
-1. Then A12, A13.
0.
A12 is 0. Then A13 is
0,
0. A21,
0,
0.
A22,
Minus cos
-cos
alpha.
minus cos alpha. Then A23,
Sin alpha.
minus sin alpha plus sin alpha.
Plus sin alpha.
Okay, sin alpha.
Minus sin alpha.
That's minus sin alpha, na? Okay. Then A31 is what? 0. A32 will be equal to minus sin alpha. Then A33 is cos alpha. Okay. So you know that this thing. So write, as I told you, write this as row 1, these elements as row 2, these elements as row 3. So write it now. So -1, 0, 0, then 0 minus cos alpha minus sin alpha, and here comes 0 minus sin alpha cos alpha. So this is the adjoint of the matrix. Then inverse is what? Then inverse is, then A inverse is equal to negative of adjoint. Negative of adjoint become +1, 0, 0, 0 cos alpha sin alpha, 0 sin alpha minus cos alpha is the required inverse of matrix. Done? Understand, students?
Yes, sir.
Yes, sir.
Okay,
Yes,
I
sir.
think I gave you 5 homework problem. Please don't forget to practice it. Okay. Thank you, students. You can leave the class.
Thank you, sir.